Now let's talk about how do you actually determine how much of a fertilizer to apply. And we're going to go through a calculation for solid fertilizers. These are inorganic fertilizers. And then we'll go through another example of a liquid fertilizer. So, how do we determine how much of a solid fertilizer to apply? So here's a conversion. Conversion from nitrogen rate to fertilizer rate for solid fertilizers is simply you take the nitrogen rate that's required by a plant divided by the fertilizer analysis in decimal form. And that is simple, and that equals the fertilizer rate. Okay. So here's an example. This example is in your notes as well. Right. So we would like to apply 70 pounds of nitrogen per acre. Let me stop there for a second. 70 pounds of nitrogen per acre. Where does this number come from? This number comes from a producer or scientist pulling soil samples from a field and analyzing that soil for the amount of nitrogen that's present in inorganic form, likely the amount of organic matter that's present, and a target yield for a certain crop. You take these values and you go to a table from one of our state's fertilizer recommendation guidelines. And you take these values that are given to you from the soil testing lab and match those up to a table or plug those into an algorithm that tells you how much nitrogen fertilizer to apply. It's relatively straightforward. It takes a little bit of reading, not much to perform this type of calculation to come up with 70 pounds of nitrogen per acre. In fact, you can take a soil sample and send it to a testing lab and tell them what crop you're growing and a target yield, and they should derive this number for you. Okay, so that's where this number comes from. So we want to apply 70 pounds of nitrogen per acre, but in order to apply this, we are going to use 4600. All right, that's urea. So what is the actual fertilizer application rate to equal 70 pounds of just nitrogen? So we use this simple equation. We use the nitrogen rate divided by the fertilizer analysis in decimal form. And so here is the math. We're targeting 70 pounds of nitrogen per acre, and the fertilizer itself has 46% nitrogen, but we divide by the decimal form, 0.46. And that tells you that a producer needs to apply 152 pounds of urea fertilizer per acre. I can tell you, you probably won't dial in 152 pounds of urea fertilizer per acre on a fertilizer spreader. Maybe you'll target 150. Regardless, that's the target application rate, right? So this is what you do for all solid fertilizers. And it doesn't have to be just for nitrogen. It could be for phosphate. It could be for potassium. You do the same thing for all those as well. So let me give you another example. Okay, here's the second example for conversion of inorganic fertilizers to match a target nitrogen rate. But this is for liquid fertilizers, right? There's two steps. The first step is identical to what you just did for solid fertilizers. So it makes it simple, right? I mean, you already know the math now for solid fertilizers. You simply take the nitrogen target rate divided by the fertilizer analysis in decimal form, and that's going to equal the fertilizer rate almost. Okay, so let's do this. Here's another example. We want to apply 70 pounds of nitrogen per acre, just like the previous example. But in this case, we're going to use urea ammonium nitrate with a guarantee of 2800. So it has 20% nitrogen. What's the fertilizer application rate? 70 pounds of nitrogen per acre divided by the decimal form of the amount of nitrogen present, which is 0.28. And if you do the math, it tells you you have to apply 250 pounds of urea ammonium nitrate per acre. But wait, this is a liquid. How are we going to convert the liquid to a unit that we can actually use and apply. So the second step to convert from mass to volume, like, I don't know, gallons or something, is to take the fertilizer rate divided by the density of the fertilizer. And that will tell you the liquid fertilizer rate that you need to apply. So when you're purchasing or you've already purchased a liquid fertilizer, there should be a density somewhere on the outside of that fertilizer. So for example, urea ammonium nitrate at 28% total nitrogen has a density of 10.7 pounds per gallon. Here's some other liquid fertilizers and their densities. So for this example, we are using urea ammonium nitrate. So we're going to take this 10.7 and plug it into the equation that I just gave you on the previous slide. Okay, so here is basically the previous slide. And we calculated step one up to right above where my cursor is moving. So what we're going to do is take the 250 pounds of fertilizer per acre and divide it by the density. Right, so 250 divided by 10.7. And when you do that and you start cross-canceling, the pounds cancels each other. And then if you remember this from, oh my gosh, from grade school, the gallons flips up to the numerator and acres is in the denominator. When you do this math, it's 23.4 gallons per acre. And that number is something that a producer could wrap their head around, right? Especially with liquid fertilizers. So you would dial in probably 25, maybe you could dial in 23.4. I don't know if you can get that specific, but you would dial in a value that's close to 23.4, and that's what you would apply. That's exactly how it is. So to keep in mind how you calculate fertilizer application rates to target a nitrogen application rate for solids, you simply take the nitrogen rate that's targeted divided by the fertilizer analysis in decimal form. For liquid fertilizers, you take the target nitrogen rate divided by the fertilizer analysis in decimal form. And then you take that new value and divide by the density.